Welcome back to my channel, students. It is the Quest Eduphysics and we are discussing about the friction. In previous lecture on friction, you learned that what is friction and what is the cause of friction, and we learnt about types of friction and as well as what is the angle of friction and angle of repose. In this lecture, we are going to learn about the motion of a body on a rough inclined plane. The motion of a body on a rough inclined plane, students. Okay, students, is the plane. I told you it is a rough inclined plane, has an inclination of theta. Okay, and a block of mass m is kept over. Okay, students, I told you is a rough plane which has a quotient of friction which is equal to mu. We need to make the body to move. Okay, here if you take this body, as you know that the weight of the body is always works vertically downwards. Let's say it is the weight. Okay, it is the weight of the body. Here some driving force has to act on this body. By the result of that, the body tends to move in this direction. Okay, so this is the direction of the acceleration of the body. Getting my students, it is the weight which is vertically downwards. And you know that where a body is kept over a rough inclined plane, it experiences a force which is opposite to the direction of the motion. Let's say the motion begins in this direction. Okay, the body is accelerating in this direction. Immediately a force will develop which acts in opposite direction to the motion of the body. Here it acts along the line, what is that, joining the contact of the bodies. By transposing, we are writing it as like this. Okay, students, is a force which is acting opposite to the motion of the body. Let's say it is the frictional force. Okay, students, then if I told you a force is making it to move downwards, and this is the force which is obstructing the motion of the body. We call it as the frictional force. The difference of these two forces provides the motion. The difference between these two forces, driving force and the opposing force, I mean the frictional force, make the body to move. Okay, to find out this force, we are resolving the weight of the body into components. Before that, you have learnt a force will act downwards. Okay, and it is the direction of normal reaction. Okay, students, it is the normal reaction. Now we are resolving the weight into components. Here it is the theta, and automatically it is equal to theta. Okay, I will tell you how it will be theta right now. Okay, students, mg as the theta. The component which is always beneath the theta is mg cos theta. Okay, students, and the next component, it is equal to mg sin theta, students. Okay, students, here actually these two are the transverse angle, students. You learnt about the transverse angles, that means transversal angles in previous classes. Okay, if you go with this, you will get the same set here. If you construct a triangle here, if it is 90, then it is 90 minus theta. In the same way, if it is theta, it is 90 minus theta. These are transversal angles. Okay, that's why we took theta. These two are the theta. Understanding, students? Let's see what happens here. Here it is the mg cos theta and it is the m. Mg cos theta balances with the normal reaction. That's why there is no vertical motion to the body. Here, what is the condition? If mg sin theta is greater than the frictional force, then only the body tends to move or moves. If frictional force is more than the mg sin theta, there is no question of motion of the body. Okay, I told you the body is moving down in this direction. That means what? Mg sin theta might be greater than the frictional force. We can write it as mg sin theta is greater than frictional force, and also okay, mg cos theta is balanced with normal reaction. That means what? The net force mg cos theta minus L is equal to 0. So there is no vertical acceleration to the body. In this case, I said mg sin theta is greater than frictional force. Then what happens? The difference between the two must be a net force. Okay, students? It is equal to Fn. Okay, then what is the magnitude of the frictional force we have to learn? As you know that frictional force is directly proportional to normal reaction. Okay, students? Our frictional force is equal to mu1. Here the body is moving. I am writing the subscript as K. That is, F is equal to mu K multiplied with N. N is equal to mg cos theta. Okay, students? Then what we have? We have this relation, and we got the magnitude of the F is equal to mu K into mg cos theta. I am substituting that value and I am rewriting this equation as mg okay, sin theta minus, here the value of the F is taken from here, mu K mg cos theta is equal to net force. Here net force is what? Net force is equal to mass of the body multiplied with the acceleration. Then see, it can be rewritten as ma is equal to mg sin theta minus mu K cos theta. Okay, mg sin theta into mu K mg cos theta. Then see, m and m get cancelled. The acceleration is equal to g sin theta minus mu K into g cos theta. Or you can write A is equal to g of sin theta minus mu K cos theta. Okay, students? In this way, we can calculate the acceleration of the body. I hope you understood how to calculate the acceleration of a body when it is moving down on an inclined plane which is provided with a friction mu. Okay. In next part, what we do, imagine this body reach the ground. Okay. Here it reached the bottom of the inclined plane. Then here we have to find what is the velocity on reaching the ground. Okay students, let's say the length of the inclined plane is L. It is, yeah, it is the length of the inclined plane and it is resting at the edge. Just imagine, it is resting means what? Initially it has the velocity of 0 and we need to find what is the velocity here. Okay students, and we have to go with the equations of kinematics. We know that v square minus u square is equal to 2as. Okay students, then it can be written as v square minus 0 is equal to 2as. Okay, it gives v square is equal to 2gl or 2al. Okay students, getting me? But we have the acceleration a, we are inserting that value. V square is equal to 2 into g into sine theta minus mu k cos theta into L, or v is equal to under root of 2gl into sine theta minus mu k cos theta. Okay, it is the velocity of the body on reaching the ground. Okay students, I hope you understood how to calculate the velocity of the block when it reaches to the ground. And what is left? The third thing, what is the time? How much time it takes to reach the ground? We have to use the same principle. What we know that v is equal to u plus at. Since u is equal to 0, you can write t is equal to v by a. Okay students, already we have the v and as well as the a. Then t can be written as v is equal to how much? Under root of 2gl into sine theta minus mu k cos theta upon g of sine theta minus mu k cos theta. Okay students, it can be further written as what? Under root of 2gl into sine theta minus mu k cos theta by, we bring it under the root, g square into sine theta minus mu k cos theta whole square. Okay students, where g get cancelled and as well as square get cancelled with this. And finally we had the equation, it is equal to under root of 2l by g into sine theta minus mu k cos theta. In this way we can calculate the velocity, acceleration and as well as the time period. Is the acceleration, is the velocity and it is the time period to reach the ground students. I hope you have followed this lecture is the motion of a body on a rough inclined plane. Just imagine here, instead of what the rough inclined plane, it is the smooth, then immediately the mu term will disappear, and what you get, the acceleration of the body, A becomes A is equal to g sine theta, and similarly here it goes on, you get, it becomes 0, then what we get, V is equal to under root of 2gl sine theta, and time is equal to under root of 2l by g of sine theta. My intention to tell was that what happens when the friction is disappeared. Once a question is asked, or maybe it will be asked, when a body is moving over a rough inclined plane, okay, if the friction is suddenly disappeared, then find out the ratio of the accelerations, velocities and time periods. Then you have to choose this relation. First you have to go with the value of the friction, then after you have to make it 0, okay, and we get the equations, then we will find the ratio very easily. I hope you understood this topic. Okay students, if you like my video, please go for the subscription and just tap the bell icon or hit the bell icon, you will be subscribed. Okay, with this subscription you will get latest videos all the time. Thank you for visiting my channel and listening my lecture students.